Hello. In this project, we will build a simple yet effective RFID-based access control system using an Arduino, an RFID module, and additional components like LEDs and a buzzer. To ensure a structured learning process, this project will be covered in a 3-part video series where we will gradually develop and enhance the system. In the first video, we will focus on the hardware setup. We'll connect the RFID module, LEDs, and buzzer to the Arduino and explain the wiring in detail. In the second video, we will register RFID cards into the system. We'll read the unique ID of each card and store it in the Arduino, allowing us to define which cards are authorized. In the third video, we will implement the access verification system. We'll program the Arduino to check whether a scanned card is registered. If the card is authorized, access will be granted, the green LED will turn on, and the buzzer will beep intermittently. If the card is not recognized, access will be denied, the red LED will turn on, and the buzzer will produce a long continuous sound as a warning. By the end of this series, you'll have a fully functional RFID access control system that can be adapted for various security applications. Let's begin by explaining the circuit diagram for the project. Tinkercad does not have wireless communication modules such as RFID or Bluetooth, so we need to implement this project physically. Our project includes the use of an Arduino board, a breadboard, a buzzer, green and red LEDs, 2 resistors with a resistance of 330 ohms each, and an RFID module consisting of an RFID RC522 reader, an RFID card, and a key fob. Since the module is not available in Tinkercad, we will carry out the project schematic using Fritzing. When you install the program on Fritzing, the RFID module won't be included. We need to log into the official website of the program at fritzing.org and download the RFID module to include it in the program. The Fritzing application is currently available as a paid version, but you can opt to download the free older version from the link below. You aren't required to install Fritzing, grasp its functionality, or sketch the circuit using the program. Rather than using Fritzing, you can assemble the circuit in a physical form by following the provided connections through the links. Now, we'll initiate the explanation by covering the power connections. We are transferring the 5 volts and ground line on Arduino to the upper row of the breadboard. And for the convenience of connections, we are also extending the same line to the bottom part of the breadboard. This way, both the upper and lower sections of the breadboard have a ground rail and a 5-volt voltage. The RFID module operates at 3.3 volts, so we connect the 3.3-volt power supply to the leftmost input of the RFID module. After the power connections, let's examine the connections of the digital lines. We will use pin 6 to control the green LED. We connect the pin output through a resistor to the long leg of the green LED, and we also transfer the short leg of the LED to the ground line of the breadboard. In a similar manner, we are making connections for pin 7 to the long leg of the red LED using a resistor connection, and it is necessary to link the short leg of the LED to the ground rail. We'll use pin 8 for the purpose of controlling the buzzer. We connect the positive terminal of the buzzer to pin 8 and the negative terminal to the ground rail for proper functionality. Let's take a look at the connections of the RFID module. The RFID module has a total of 8 pins. The leftmost pin is dedicated to the 3.3-volt power connection. The pin next to it is the reset pin. Pin 3 is the ground connection pin. Pin 4 is the interrupt request pin, but we won't be using it. Pin 5 is labeled as MISO, pin 6 is MOSI, pin 7 is serial clock, and pin 8 is serial data. The details of which Arduino pins these connections are associated with are written below. We connect a 3.3-volt voltage from Arduino to the first input. Connect the reset pin to Arduino's pin 9. Connect the GND pin to the ground line. IRQ pin remains unconnected. Master in, slave out pin to Arduino's pin 12, and master out slave in pin to pin 11. Connect the serial clock pin to pin 13. Finally, we connect the serial data pin to pin 10. With these connections, our circuit diagram is now fully depicted. With reference to the circuit drawing image, you can render the circuit in a physical representation. In the next video, we will move on to adding the necessary libraries for our project and writing the commands.